Hello everyone. So I will expect that this is the latest video, I hope, of this motor controller, because there were some comments that with some doubts regarding if the controller can be managed or controlled by an external Arduino because it has some UART pins, if we can add end stops or whatever. So we are going to answer all of these questions right now. So please, if you find these videos interesting, subscribe, give it a like. You can take a look in my Instagram as well. I used to post information time to time, more often than in YouTube. So let's go to this video in which we are going to show how we can connect first end stop into the controller. And second one, how we can modify parameters in the controller with an external Arduino. One thing that we need to take in account first is that all these will require some soldering skills, not high-end, but a bit, just to warn you. So what we need is the controller, and we need to solder some pins internally and have access to them, okay? So the first thing we need to do is to remove this cap here, that it's really easy, and we are going to see the PCB here, okay? The important point is that we have two connectors here and one here. In this side you see that I have already soldered the header, but on this one there is no. So both sides they will come with this style, no header connected to it. And what we will need to do is to solder two headers, one here and one here, that I am going to show you. So first thing is to locate where we need to solder these headers. So basically here, let me see if the camera focus here, we see that we have enabled direction pulse DC plus DC minus here. We don't need to solder anything. But here where we see these signals, which are the control signals, we see come, stop, backwards, forward, and fan. That fan currently is not in use. So we are going to solder here a header, and here we can see GND, RX, TX, and 5 volts. Here we are going to also solder a header. In this case, only if you want to control the parameters through an Arduino and MODBus. So to extract the PCB and to solder them, the only thing we need to do is to remove the cap and open these small fingers here as well, in a way that we can extract the PCB on this side, and we do the same on this side. Okay, so as you can see, it's really easy. We will extract the PCB, and what we are going to do basically is to solder this header here going out and this header here. Okay, so they are 2.54 millimeter headers, so nothing complicated. So now once we have them soldered, we need to put it again in the same position as you can see here. So basically we put it here, we press, and we put the encoder. So it's working again perfectly, already assembled. Now that we have access to these pins and to these pins, we are going to connect the end stops. Okay, so what happens if we want to have some end stops in a way that, for example, we select to go to the right side and stop it. So I have prepared here a small setup that basically it will show you how this works. There are two switches here, one here and one here. As you can see, you can press them. They are going to be pressed by this part. It's just to show you graphically or in real application how it works. And when this part is touching the switch which is in this direction, it will stop, and the other way around as well. Okay, so what we will need to do is to buy some switches. Here is just one example of an end stop. Important thing is that they are mechanic ones, because if we use inductive end stops, we will require external circuitry that currently we don't have, and we are not going to overcomplicate things for this simple controller. So basically what we need to buy is an end stop that, as you can see here, it has the common one, the C1, and normally open, normally closed. So we need to buy the ones that they are normally open, as you can see here. that when we press, the normally open become close, and it will be electrical connection between both. When we open, there is no electrical connection. So we need this kind of end stops. There is also this version that it has the 3 outputs, but as said, we are only going to use the normally open. So I have replicated this setup here with these 2 switches, and ideally, or it will be like putting this here, okay? So now I am going to put you a schematic in the screen or in the video, in a way that we are going to take a look how to connect everything in a way that we can set up the controller in order to work with this end stop. Okay, so basically these are the connections that we need to use. So we have here a pin that it is called forward, one that it is called backward, and one that it is called COM. So these are the pins that we are going to use. And basically we need the 2 end stops, the end stop 1 and the end stop 2. So basically the way we need to connect this is really easy. So basically we take a cable here, and we join them together, and this join we are going to connect it to the COM, right? So we connect this to the COM, and the other cables, one of them we are going to take it to the forward, and the other one we are going to take it to the backward, okay? In a way that if we are going in the forward direction, so basically in this way, when the movement press this switch, it will stop, and when we are going in the other direction, when the movement press this switch, it will stop the direction or the movement in this direction. So now we are going to the real world, and I'm going to show you how to connect it, and we are going to do some trials. Okay, so after seeing the diagram, the connections, now we are going to this small setup that I have prepared here. So I am not going to enter into details how to configure the motor controller. It's on my previous videos that you can see them on the description. But I will focus how to connect the end stops, okay? So basically we have end stop 1 or 2 and the other end stop, so basically the 2 of them, and the connection is really simple. So as you can see here, we have the gray cable that it is going to one of each pin of the end stop, so connecting them together here, and we have the output, okay? So this common pin needs to go to the COM signal that it is here in the extreme, as you can see here, the first one, okay? And now one important thing to consider, okay? So we have the clockwise direction. This means that the motor will go in clockwise, ideally. This is something that you can check, but so it is going in this direction, okay, into the left. We are going to see later if it is okay or not. So this is clockwise, so it's going in this direction. So basically what we are using is this end stop as to stop the clockwise, means that we need to connect it to the forward pin, okay, which is the fourth here, okay, the forward. And this is important. If it is the other way around, you can always invert them. And this one, we are going to connect it to the backward, which is the counterclockwise. And with this simple connection, what we are doing is override these switches, okay? So it means that when we press the clockwise, okay, the motor will start moving clockwise, and when the motor has pressed this switch, as you can see here, this is like if you would press the clockwise again. So the motor will stop. What is going to happen is that it will remain shorted or closed, and even if you push, it's not going to go more in this direction. The only way to output this state is pressing the other direction, in a way that the switch will be released and it will go till the other direction, and it will work in the same way. So basically what we are going to do now is to connect the motor. Let me connect it in this way, okay, and connect the controller. Okay, so let me put this in a better way. I think this is the best way we can do it, because the cables, they are not so long like this one. Okay, so now what you can see is that if we press clockwise, as you can see, it's going on the other direction, right? So what we can do, because if we press this one, it's not going to stop. As you can see, it's going to only change the direction. So we have figured out that we are in the other way. So basically we invert the pins, and this is something that you need to check. Here we invert them and we are ready to go. So now if we press clockwise, it's going to go to the end and the stop, as you can see. If we keep pressing clockwise, nothing happens, it's not moving. And if we press counterclockwise, let me speed up this a bit, it's going to drive to the other direction and stop. And we cannot press it again. So as you can see, it's working as Endstop, so we can set the two directions and the, let's say, the control will stop immediately, okay? And for sure we can always stop wherever we want and change also the direction, but the movement will be contained between these two positions, right? For sure we could use the run stop in order to stop the movement. So because we can access from outside like this one, we will connect it to the stop and it will work in more or less similar way, but we could not, let's say, go to one direction and keep there, right? So we will not be able to restart. It's a bit complicated to do it in this way. So the easiest way is to do it like this. So we use two end stop, one for the clockwise, one for the counterclockwise. You already saw the schematic, how to connect it. And I think it's quite simple, so we don't need anything more specific. Some things to take in consideration is that I recommend you to use switches, so not inductive end stop as said, because it will not work as easy as it will do with this one, right? So I would say that it was quite clear, the explanation. I think it will cover the doubts that the people had regarding how to connect, let's say, Endstop. And one more thing we need to take in account. This is also applicable for putting if for example we have the controller inside of a box and we want to put the switches outside. So this is working in the same way, right? Because if we put a switch, it's working in the same way, as you can see. So I think it was easier. Now what we are going to explain is how to control or tune the settings externally with, for example, an Arduino through the UART port. So let me prepare the setup and I will show you how we can do this. Okay, so we continue with the connection. In this case, I'm going to use this small PCB, and what we are going to use to control the motor controller, it's a bit redundant, is an Arduino Nano, as you can see here. The only difference is that it has USB-C, but it doesn't matter. So I am using this PCB because I will say that it is the easiest way for many of you to connect the Arduino to the controller. You can use also a breadboard like this, but yeah, to show you it's easier this. I will link you in the description the Arduino and this small connection board in case needed, and also I will use these DuPont cables. Okay, you can find everywhere. There are better ways to connect everything, but I am going to do it in the simplest way. So basically what we are going to need is to insert the Arduino in this board, okay, like you see here, and ensure that you have the pins aligned, so inserting, deserting. Okay, so we have it ready. Yep, take it with your fingers. So basically we have the pin out here on the Arduino, on the output. In this example I am going to power it through the USB, but you can always power it from a power supply, for example. Take care because you cannot apply more than, I think it has a voltage input that you can apply 9 volts, but I will not go higher. So basically what we need to understand is that we are going to use the UART, which are these 2 pin here. I hope you can see it, some digital pins, but that we will randomly select, and that's all, the GND for sure. So we don't need too much things. So what we are going to connect right now is the UART. The UART has 3 cables. So basically it has ground, that for the moment we are going to insert them in this way. As you can see here, ground. Perfect. So this is ground, the 1, 2, 3, 4, 5, 2, 3, 5, and as you can see we have here TX. So as you can see here we have ground, we connect ground, and we have TX and RX. So we are going to connect TX and RX as well. So we connect both of them. It's screw terminals, so I would say it's really suitable for this application. And this one. So as you can see, it's fixed, it's perfect, and we are going to use 3 more cables. So one is for another GND, like this one, you see here. So GND, we insert it. Oh. I will say this side they are not open, so let's do it in this. Okay, insert it here. As I said, you can use also breadboard or whatever PCB you want to use. And in my case, I'm going to use the digital pins in order to control the movement on the driver, or in this case on the motor controller. Sorry. So basically, we are going to use D5 and D6, but you can connect it wherever you want. Always considering that you need to use digital pin. Analog will work as well because they used to work as digital, but yeah, why not? I mean, why we should waste analog pin for this purpose that can be digital. Okay, so we have this connected and we have all the cables already fit, right? So what we need to do now is connect it to the controller. So if we have here the controller that I will disconnect it from here, it will be easier to see. Some focus. Here we have the UART that we see that we have TX, RX, 5 volts, and GND. So basically, what we need to do is to connect it inverted. So the TX on the Arduino, okay, this TX needs to go to the RX on the controller. The RX on the controller needs to go to the TX on the controller. Okay. So basically, if we take the cables, the green one is TX, so we are going to connect it to RX. The blue one is the RX, so we are going to connect it to the TX. And the other one, which is important, is the GND, that we are going to connect it to GND. So now we have everything connected on this UART, and now we need the control, okay, of the actuators for the direction. For the direction, we have 3 cables. The GND that needs to come here to the COM, here, and the pin, in this case, the blue one is the pin 5. If I don't connect them wrong, yeah, exactly, pin 5. So the pin 5, we are going to connect it to forward. Means that when we enable the pin 5, we go forward, and the other one to backward. Okay. Forward and backward. With this, we can already make the motor controller works using Arduino. As we already mentioned, it has some limitations. Okay, so we can select the speed and some other features that we are going to see now in the computer. But in case you want to use Arduino, for example, to add more Endstops or more variables to the controller, let's say, or imagine that this is useful. Imagine that you want to do a movement right at 200 RPMs, and the left movement you want to do it at 300. So basically, with the Arduino, you can change the speed. Let's say real time. You don't need to be here. So that's why I think depends of the application is useful. One thing you need to consider as well is that there is a Arduino library for motor controlling. I never use it. Theoretically, you can control these kind of drivers with an Arduino as well with this library, but as I said, I never did. So in this video, we are going to focus to show how to control this one, and the TX and RX. It will go through MODBus. It's industrial transmission, theoretically, or used to be with RS485, but in this case it will be just TTL, or so standard voltage levels 5 volts in this case. So outside, to repeat, we need Arduino. The UART needs to work at 5 volts, 2 digital outputs, and connect everything to the motor controller. Okay. And now we are going to go to the computer. I will show you which library I use, how I use it, how it works, and small code that I prepare in order to make this work. And probably I am going to insert you some small videos how it works in the small code that I did. So let's go there. Here we have the code that I have done for the controller, or to do a basic control. I will upload this one. You will see it in the comments. So basically, the first thing you need to do is to have the Arduino environment. You can do this either here. This is Platformio with Visual Code, or in the Arduino IDE. It's not a problem. You can use whatever you want. The only important thing is that you need to download this library that you see here, the MODBus master, okay, that I will leave you in the comments, and install it. Once you have it, there are minimum things that you need to do, okay? So basically, for the enabling the MODBus, you need to put this here as node for enabling all the features. So basically, this is needed to create the structure, and we are going to define some pins. In this case, the pin for moving forward is the number 5. The number 6 is for backward, as we have connected on the Arduino, and the LED that you are not going to use it. So let's say if you select here forward, you need to connect the pin 5 to the forward pin on the motor controller, and the same with the backward. Okay, this is important. So on the setup, what we are going to enable is the serial begin for the MODBus, because it's working through UART. Here we are enabling the MODBus, or the object. The first parameter is the MODBus slave ID. So basically, it's something that we are going to see in the manual of the driver, as you can see also in the screen. So basically, set the device address. We can put here from 1 to 255, which is 8 bits, and this needs to be correlated to this value. And later on, we start the serial, and this name here needs to be the same like this one, okay? Because it's the UART that we are going to use for this purpose. One thing you need to take in consideration, the Arduino Nano, it has only one UART. So it will share between programming and loading or working with this MODBus. What this means, while we have the Arduino Nano connected to the motor controller, we cannot program it, okay? We need to disconnect the UART, so these two pins, the TX and RX, and then we can program it. We connect them again, and we work with the code as we want, so quite important. So basically here what we are doing is select the pins that we are going to use. So basically pin mode, pin 5 as input, and pin 6 for backward as input as well. For the moment, we are going to connect them as input because they are going to work as high impedance in order to don't do anything. So that's the reason. The Arduino has not real open drain configuration, so we are doing it in this way. Okay, so just put the mode at the beginning like this, input for both, and they should work. And now we go to the loop. what we are doing here. This is only for me, for debugging. You can use the LED or not, whatever you want. But now these three commands, they are the most critical right now, okay? Because what these commands they are doing is to write on the motor controller, let's say, registers. As we can see in the manual, so if we scroll down, you are going to see it in the screen as well. At the end, we see here a MODBus control method, and basically it is explaining how this works, that we have 13 kind of messages that we are not going to enter into details. You can also read for the or from the controller, but it's not the focus of this. And you can also write. So right now what we are doing is write, and what it is important for us is these registers that we see here. So basically I have been taking a look, and I think there is a mismatch between the registers and the real values, because I can tell you something. If we see here the forward rotation speed in RPM, we see that the address is 2. This is not real. So as you can see here, if we go to this command, we see address and value. Okay, so the first number here is the address, and the second one is the value that we want to go to, we want to give to the register. So basically, the register for the speed, I can tell you that it is 3, okay, for forward, and 6 for backward. Okay. We will need to analyze the rest of the registers. I think these are the two most important ones. If you want to take a look, feel free. So you can play with this. Once you already know this command that it is writing on these registers here, it's easy to try it. So the three registers that you can see here, what they are doing is basically select on the register 0, which this is real, the mode, which mode 3 is continuous working. So when we push one button, you can see it in the second video, I will say, or the first one. When you push the button, start running. When you push it again, stop. So the way of working that we want. And here what we are doing is set the speed. In this case is 3000 because I changed it, but we can put here 250 and 250, okay? What it is important also to know is that we need to multiply by 10. Don't ask me why it is like that. It is not shown in the manual, but now you know it. So basically, if we want to have 250 RPMs, we put 250 plus 0, so multiply by 10. And with these two, we configure the speed. And now what we are doing is easy. So basically, we are going to move forward for 2 seconds, as you can see here. So basically 2 seconds or 2000 milliseconds forward. So basically we are enabling the motor, wait 2 seconds and disable the motor, okay, and wait another 2 seconds. And here what we are doing is enable the motor, but in this time backward, wait 2 seconds and disable the motor. And you might ask, but what this function does? So basically it's really a basic function to controlling the pins that I will show you here. So first we ensure that the direction pin, so let's say here in the direction we are inputting this variable here, that it is in this case 6 and in this case the pin 5, pin 6, pin 5, as we already said, and we are inputting into here, right? So the direction is defined by this one, or the pin, and at the beginning we are setting the GPIO as output, so we are going to send a signal. We are going to need to put it high because the default status of the switch is high. We are going to wait 100 milliseconds just for settling, and we are going to put it low. So what we are going is like if we imitate a pushing of the bottom, and after this push we are waiting 100 milliseconds and we change the direction of the pin to input. So it's again high impedance and we don't create a second pulse or whatever. And basically what we are simulating with this function is when we press one of the buttons once, means that if here it's the motor disabled, so we are going to enable it, and here since it is enabled, we are going to disable it. You can have more intelligence on this code for sure, but I just wanted to show you how this works. So you only need this command from the MODBus library in order to change the speed, and this one for simulating the pulse. So that's all you need. You can also assign read registers, but we are not going to enter into that detail because it's not the main function of this controller, right? The main idea is that we have it standalone. For sure, bringing Arduino will give us more features or more possibilities, but yeah, I just wanted to show you the basic stuff, and later on you can develop more in case you want. So as you see, we are selecting the mode, changing to 200 or 250 the speed in both directions, and in one direction will go 2 seconds and on the other one another 2 seconds. What we are going to do is to see the manual, okay, and I will show you a bit all the things that theoretically we could do. So as you can see, we can set here the rotation speed in both directions, but as said, they do not correspond. Again, important, take a look to my code. It's 3 and 6. And also we could read speeds if the motor is accelerating, decelerating, and another several informations, but I let you freedom in order to test this by yourself. So now what we're going to do is change to the setup that we have on the table, and we are going to see how this behaves. Let's do a demo about the code that I have shown you in Visual Code or for Arduino. So we have the Arduino, the motor controller, the driver here, and the motor. I have this picture and I showed you before, and we are going to see how this moves. Okay, so basically what this is going to do, as we discussed, is moving forward 2 seconds at the selected speed, and stop 2 seconds and moving backwards 2 seconds at the selected speed. As you can see here, we have another speed selected here, so you will see that it will change automatically without doing anything. And one more thing you need to take in account is that if you want to load the code in the Arduino, okay, you will need to disconnect the UART, because as I said, the Arduino Nano has only one UART and it is used for both purposes, okay? So when it is busy with the controller, you cannot program. One thing that you could do in the code is just to disable the UART, and theoretically it should be possible to load the code directly if you are not using the UART anymore. So let's do a try. We are going to press reset and it will start. Okay, so you will see that the speed change. This change take like some milliseconds or seconds, and now it's going to start. 2 seconds, 250, and 2 seconds, 250. So as you can see, it's really easy to program these small controls, and you can use really basic Arduino. The library is working, the connection is working, and yeah, I will say that the connection is working. So this is what we can do together with the Endstop to add one more layer of extra control. I hope you enjoyed the video. Please give it a like, subscribe. I am going to do more videos regarding this kind of controllers. I have one in the pipeline for DC motors, and see you in the next one.